All right, so this is another fourth question, again in the group of new questions, for which I haven't done the homework help videos yet. And this is near the end of the homework set. I thought I would do those first because that's where there's particularly greater number of these new questions. So let me read the question. It says, find an equation to determine the magnitude of the net force required to stop a car of mass m. Let me just start doodling. Again, I just want to make sure I'm not forgetting any information. So car of mass m, and we are talking about stopping it. So I guess it has some initial speed of v naught. Okay. And oh, we are okay. Magnetic net force. Oh, stopping distance. Okay, so we know how far it's gonna travel to come to a stop, and here it'll come to a complete stop here. So as you kind of look at the information given, especially after we have done the kinematics problems last week, I hope this v squared formula is what comes to your mind. Mainly because this setup doesn't involve any time. So the v squared formula, v final squared is equal to v initial squared plus 2 times acceleration times delta x. That's what will be particularly convenient because it doesn't have to go through time information like most other kinematics formulas do. So now the question isn't asking for acceleration, it's asking for magnitude of net force. But hopefully you remember Newton's second law that says that net force is equal to mass times acceleration. So if you have acceleration, then you are only one step away from figuring out the net force. So let me take this expression here and solve it for acceleration. Let me first do the algebra, then I'll worry about the signs. So just solving for acceleration in my head. If you need to, pause it and write it on a piece of paper. Acceleration is equal to the final speed squared minus initial speed squared divided by 2 times, I wrote delta x here, but eventually I'm going to need x, so let me just write it as x. Now, here the final velocity will be 0. It's gonna stop. So plugging that in, it's gonna be minus initial speed, v naught squared. So minus v naught squared over 2x. So from here, if you want net force, that would be mass times acceleration. So it would be minus mv naught squared over 2 times x. And here's where, so I do like reading the question carefully, and it does say magnitude, which means the question is looking for an absolute value of this. It's not looking for the signed quantity that also indicates the direction. So the answer here ought to be mv naught squared over 2 times x. And I can check the units: kilogram, meter squared per second squared divided by meter. So kilogram times meter per, so kilogram times meter per second squared. That's the right unit for force, I think. So I think I did everything correctly. Let's type it in. Now with this kind of algebra questions, there'll be a little bit of a help here. This toolbar, it helps a little bit, in particular with the variables. Sometimes it might not be clear to people how to enter something like v subscript 0. You can type it on keyboard. If you do v underscore, then that moves the cursor down, and you can do that. But if you don't know how to do it, then you can use this toolbar. Just click v naught. So let me do m first. M. And with my open math, you can do implied multiplication. You could also put multiply thing on it, but you can just click your way. I need to type 2. And let me get out of here with the right arrow, and then divide it by, what happens if I, okay, and then 2 times x, variables x. So that's one way to enter it. Let me make sure I got it correctly. Okay, find the magnitude of the net force. Oh, we are just plugging the numbers. Let me do this in Wolfram alpha. That way I don't have to worry about unit conversions. I will just put in all the quantities as the full physical quantity with the unit, and Wolfram alpha will do the conversion for me, and I look for the answer with the newtons as the final answer, the final unit. So mass was 960 kilogram times V naught squared. So 43 kilometer per hour squared. Make sure you're squaring the whole thing, not just the unit or the number. Divided by 2 times stopping distance of 26 meters. And after you enter it, with Wolfram alpha, one of the nicest things is it tells you how it understood you. Make sure its input interpretation is correct. Then you look for, there is this answer in newtons. 2634 newtons. And it gives you a bunch of other units like kilonewtons and customary units and all that. I mean, it can be good for learning about different units if that's what you're going for. Here, all I'm trying to do is get the answer.